Okay, my brilliant math 20s. We're going to talk today about these hills. We saw some of these really steep ones. I can confirm, by the way, that Whitefield Valley Road, that's the only one of those that I've ever actually been on. But that road, holy smokes, if you're trying to walk up it, it's like, you walk for like 1 minute and then you're out of breath. A serious steep hill is one of the best things you can do in terms of like heart health, but also pretty hard. Hard on your heart, or if you're doing a vehicle, pretty hard on your car. And that's actually why there are signs like this on roads. So if you see a sign like this when you're driving, sign like this, it's telling you something about the hill. Any idea of what this 8% thing means when it says 8% on that sign? Yeah, so it has something to do with the incline. Does anyone know what an 8% incline is? Does that mean like it's 8% of the max incline, or does it mean it's 8% hard? Or like what's it trying to tell you? 8%. What would that mean? Now, what would that mean, this percent grade thing? Not yet. Where's yours? Oh yeah, you said there. Yeah. Oh yes, and you won't have one yet either. So what the percent grade means is, if we're thinking about yesterday, percent at its core is amount out of 100. So if we're thinking about slope as rise over run, all that your percent grade is telling you is what the rise is if the run is 100. So it's basically saying that, like, if you were drawing this as a triangle like this, it would be, for every 100 run, it would be 8 rise. Right? So a flat road would be 0 out of 100. And as you increase that percent grade, it gets, more and more percentage rise versus run. And you can imagine that a 100% grade, right? You're talking about pretty significantly steep hill, a slope one. So that's our marks. So to find percent grade, we're basically just asking what's the rise out of the run, and then times 100. Rise out of run times 100%. And if the slope is higher, it's got a higher percent grade. I won't quite move on yet. I want you to be able to write this down. As you're doing this, I'm just going to check in our attendance here. Now, one thing that you may be thinking of, some of you more brilliant ones up there, you might be thinking, wait, so what would be like rise over run? Rise over run. So if it's steeper, it's higher grade. So if you had a hill that was a 100% grade, well, that would be because it has like the same rise as it does run. It would actually be a 45%, right? Like if you had a 100 and 100, you would have an isosceles triangle. So these would each be 45 degrees. And so if we're talking about degrees, we're not saying like a full 90-degree angle. We're saying like percent up to 45 degrees. Yeah, so that's how that goes. So Highway 56 on Hooper Highway. This is a road I used to drive quite often. I used to live in it out there. And there's a section of roadway that rises 1.6 meters for every 20 meters of run. Okay, welcome, Paul. So 1.6 meters for every 20 meters of run. So what would be the percent grade? Let's see. Percent grade would be, first of all, rise 1.6 meters for every 20 meters of run. Right? So we're talking about rise over run. So we go 1.6 divided by 20. 1.6 divided by 20. So we end up, what percent grade is that? Well, that's 0.08. And then we go to find the percent grade, we're times 100, is 8%. maybe probably would have been good actually to say initially here, percent grade equals rise over run times 100%, just to kind of clarify what we're doing. Right? The way we're going to find percent grade is figure out the slope, multiply by 100%. So what's the slope of a road with a grade of 6%? Well, if we know percent grade equals rise over run times 100%, this whole part here, rise over run, that's your slope. That part's slope. So we were told that percent grade is 6%. That equals slope times 100%. So the way that I find what it is for slope, divide by 100%, divide by 100%, and we find that m equals 0.06. Or I know some of you guys, you love your fractions, that's fine. Same thing would be saying 6 out of 100. Or right, these are all ways of expressing slope. The big thing today is just recognizing, yes, we can also express slope as a percent grade. That's what you'll see like on road Seems like mostly a helpful thing to me, to be able to know how steep the hill is. You'll actually see sometimes beside that sign on the road, percent grade, and then it'll also say like, put on chains if you're a certain truck or something like that. It's basically telling you, if it's up to this steep, you should be fine, but above a certain percent grade, depending on your vehicle, you won't be able to go up to it. Let's there. Is your book up there? Yeah. Now pitch, another way of expressing the same thing, except in this, we're just doing it as a ratio. So this would be rise compared to run. So like that last one, we were talking about percent grade, it was like 8 out of 100. Well now pitch is just saying rise compared to run. How much does it rise for every time? It's basically how much is the vertical change versus the horizontal change. So simply put here, pitch of a roof is 3 to 5. So we know, proportionally, that for every 3, this is 5. Right? For every 3, this is 5. But it actually says, but the roof is actually 10 feet wide. Now if it's saying wide, are we talking about run or rise? Yeah, the run, okay. So if it's this wide, that's the run. So let's set up a proportion. Let's go back to Math 10.3 for a minute. Set a proportion as a block different. So we're saying the pitch is 3 out of 5. But we want to compare this to 10 as the run, something as the rise, right? Okay. So when I have a proportion like this, 3 out of 5 equals x over 10, how do I find x? Sorry? Well, I don't think we'll need to in that case. That might make us a bigger number than we need. All we're looking for is the unknown here. Proportion, 3 out of 5 equals x out of 10. Go for a second back from like trying to do something fancy with math. 3 out of 5 is equal to something out of 10. Is there just like some intuition that tells you probably what that is? What did it take to go from 5 to 10? How'd you multiply? Times 2? So what should we do this? Yeah, thank you, Sean. Sean can communicate with sign language. Thank you. Yeah, I agree. If it was times 2 to get to here, it better be times 2 to get to here. For x equals 6, the rise is 6 meters. Now the other thing I know a lot of you got really used to in Math 3, and this is perfectly fine, is just doing the cross multiply and divide. So if you have x over 10 equals 3 over 5, you can just take 10 times 3 divided by 5, you get x. 10 times 3 is 30, divided by 5. Oh yeah, okay. What about this one? What about this one? What's the pitch of a roof that has a height of 3.5 and a width of 9? A height of 3.5 and a width of 9. Now this is actually a little bit tricky here. Let's sort of think about this. So I see this triangle, I see this triangle having this height, but if I'm thinking about the width, for each of these hills, it's not really having a run of 9, is it? Like, if I was talking about, for example, this height, or this height, well, the rise is 3.5, but the run is actually only half this 9, isn't it? The 9 meters is the whole thing, but really the run is just half that. This would be 4.5, this would be 4.5. Am I right there? Seems like cut the thing in half. This is actually, rise over run, or rise over run. So I see the hill, if I had just drawn it like as a simple triangle, was 3.5 rise to 4.5 run, right, for each of those triangles. Okay, so if I have, m equals rise over run, I'm trying to leave that as a ratio. It feels to me like leaving decimals is a little bit kind of crude. I'd rather use whole numbers. So if I have both of these as numbers that are something 0.5, how can I make it so both numbers instead are going to be whole numbers? What might be a natural step there? How can I change a fraction like this to a fraction where there's no decimals? Sure, let's do it. I agree. Seems easy. Some people are like just like whispering it in their mouth because they don't want to say it. Seems too simple. But for some of them, you just need to think through it. Yeah, I agree. Let's go just times 2 over 2. Good idea. So the slope would also be 7 over 9. Would be another way of expressing this. And this is funny. I find some people actually almost find this tricky. There's really sort of 3 ways we can express slope. One of them is just saying like slope as a fraction. One of them, this one where we're talking about pitch, is when we express it as a ratio. So the pitch of a roof, the pitch is what we just say is rise compared to run, or 7:9, 7:9, right? It's the rise, then the run. So that's the way we would sort of set this up, is rise over run, that's slope. This is pitch. And if we had wanted to find percent grade, we would then just go 7 divided by 9 times 100%, right? So slope, pitch, percent grade, we're all saying the same thing, just expressing this one as a fraction or as a decimal, this one's as a ratio, and then the final one's as a percent. Cool. Okay. I'm guessing actually for today's lesson you probably need a little bit more support. Right, Ellen? Yeah. Good morning. Nice to see you again. I want you to start working on the homework though. Yeah, let's see how that goes. I'll be doing some wandering. Recognize working with each other is probably good idea today, just because the which thing is being asked for is kind of the only real tricky part here. Are we asking for as a ratio or as a fraction or as a what? Yeah, just 10 up.